Hello. Today I'm going to walk through this new wallet Infra project, which, as we can see, was just released a few days ago. This is kind of, I think, more of what I was wanting to accomplish with the SPV wallet code that we looked at last week. So let's dig in and see what this thing is. So my understanding is the SPV wallet is kind of a it's a paymail server that does UTXO management, but it does it very much in a very specific way. It's kind of even considered a bit of a legacy way for how it does key derivations and things like that. And this is a new project that kind of is a different approach to hosting your own wallet infrastructure. So let's see what we got here. So out-of-box UTXO management. Server automatically handles all core wallet storage actions. I believe this is far more generic than like what the SPV wallet does. We've got a connects ORM library in there. Looks like there's monetization built in for you running the wallet. So you can charge for APIs and such. It's got bidirectional authentication. I'm sure that's using Bitcoin keys. Comes with MySQL. Well, that's just an example, but you can use with Postgres or SQL. Makes sense. Wallet storage manager class can handle multiple active or backup storage providers. Okay. Storage server class is an express base. Each you can add your own routes, middleware. Okay, whatever. All right, well, let's give this a go. All right. Clone a repo, Bitcoin, SV. Oops. I don't think I did that right. Clone a repo, clone from GitHub. There we go. npm install. And by the way, I am going to start trying to keep an eye on chat on these streams as well. I don't multitask that great. It's funny, when I was younger, I always used to think I was really good at it. And as I've got older, I realized that maybe that's not the case anymore. I'm good at writing code that multitasks, though. Okay, so we need some environment variables. We've got this local. I don't like how everything. I mean, I like how. First of all, I very much like Docker Compose for running things, but I don't like that everything is all packaged up and you don't really get. Well, we'll start this route. Okay. Well, let's do that. Let's take a look at what this has got. So it's got one server and a MySQL image. Okay. It does have a private key in there. I do not like that they're going away from the WIF format into just hex. But, oh well. Okay, so let's go docker compose up. Gracefully stopping error response from driver daemon. Oh, you know what? Do I have others? What? PS is what I meant. Okay, I had a bunch of stuff already running. Let me go into this PV wallet, docker compose down. Apparently I left your stuff running from last week. We had a port conflict. All right. Okay. That doesn't appear to work either. But, all right, we're going to stop all this. Since it's just the two containers and one of them is just a database, and I think I'd prefer to use SQLite anyways. Okay, it does support a .env. Let's go back to the README. Let's go back to it here. Don't care about deploying at other places. All right. Let's just see if we can run this thing and see what happens. Let's look at our package JSON at the scripts that it's going to start. So it's expecting to start out source index.js. So there's a build process. Let's go npm run build. Okay, now that exists, so I can go npm start. Server private key must be set. Makes sense. Now let's go to our index file. Are they running? Yes, they are running .env. Cool. So I should be able to just put a fact. Should just be able to take this. I'm going to have to figure out how to pass in SQLite to a Knex DB connection. Well, let's see where that variable is used. Reads it from process env. If it's not set, it parses it. Looks like it's got default setup for MySQL. All right, let's do a little searching here. That's really white. And I guess I could stand up a MySQL instance, but I'm try to stay mostly in the Postgres and SQLite worlds. This is not what I'm looking for. See if they've got types here. Can I go? I don't know if that means anything or not. I don't want any pool stuff. Let's go into this make connects and see what this does. Find. Wait. There we go. Just click through. I don't know what I was doing. That's just a declare. So that doesn't have any actual implementation. Okay. Well, I guess I'm just going to try to go back to the Docker Compose and try that for now and just see if I can get this thing up and running at least. And it appears to just work this time. All right. Nope. Nope. Yep. Yeah, just works this time. Okay. Now, how do I figure out? I guess we're probably going to have to dig through the code some. I should double check. Can you all see? Make this one size bigger. Okay. So what do we got here? This is just an initial setup. There's got to be something that kind of starts the server running. It's probably this services storage server. I do not like it when VS Code does this. Go right to it. Storage server. Okay. It gets a wallet. We'll look into what that is later. Monetize. I assume this is some sort of a drives the middleware for how you charge. Okay. A single post endpoint. Okay, because it's all JSON RPC. Is there anything in the docs that go into the actual way to use this? Let's go back up to the top. Is there any links? Okay, so there's this wallet toolbox, which I guess is a client for this. Let's go to that project and check out what that is. Oops, I'm going to do that in a new tab. Okay, that's a broken link. And I just closed the wrong window. Okay. Documentation. Just tried that, but I'll try it again. Site not found. So again, the main use case I'm trying to figure out is how do I, from an external wallet and an instance of this Infra running, save my transactions such that they will be included in a transaction history such that next time I stand up that wallet on a new device, I can download it or something. I can sync with it, I guess what I mean. All right. All right, we're gonna have to dig in and figure this out, and I'm okay with that. Let's see here. I was just in. Wait, does this have other libraries? Wallet storage. Okay. So there's another piece that's probably what I actually want to be looking at. Wallet storage. Oh, let's go over to NPM. P2P, this is not a BSVA project. And I don't have permission to it. Well, that's not good. Okay. So I guess let's click into it the hard way. Oh, but I think we just have types. No, I was in there a minute ago. Where? Not there. I was in storage server. Where does storage server come from? That is, must be defined here somewhere. Wallet infra, node modules, wallet storage. Okay, this is from that wallet storage project. So let's. Okay. Find or insert user, get settings, destroy. There's got to be more. There's got to be more functionality than this. Let's go back here. That's just the server. Chain new services, key driver, wallet signer, wallet. I guess let's go one at a time. You know what? We're going to start from the top and work our way down. Okay, so we got some database config stuff. Not worried about that right now. There's a root key. Not worried about that right now. There's an identity tied to that using its public key. This is, again, is just our database, our storage setup. Migrations. Settings equals make available. Wallet storage manager. Services. Key driver, wallet signer, and then we just start the server. And this is setup, which I'm sure is just called in the same index file. Oops. Yeah. We call start. Okay. So we already looked at the storage server. There was not much there. So options for it. We've got the wallet. Let's see what the wallet is. Get services, okay, so we have get known TX IDs, list actions, which I've been told now I was very confused about the wording around these actions thing, but I guess this is just a transaction is essentially what an action is. So I don't know if this is listing, I think this is listing the transactions that this wallet holds. Maybe. List actions. Let's go into it. That's just an interface, but it returns list action results, which has an array of wallet actions. And a wallet action has transaction ID. It has Satoshis. So Satoshis, I mean, it might be how many Satoshis are in the transaction. What do we have for status here? Completed, unprocessed, send. Okay, so these are definitely transactions and status within the transactions. Is outgoing, I assume, means am I sending things to other people in this? Description. Description string 5 to 50 bytes. I like it. Labels starting under, these are very descriptive types. String under 300 bytes. A version, a lock time. Okay, so this is really metadata about the transaction, which is probably the transaction itself parsed. So let's go to a wallet action input. So this is our import source input, source Satoshi, source locking script. Here's our unlocking script, a description. And okay, so this is everything required to create a transaction with those inputs. Uh-oh, lost. And then wallet action output. Satoshi's locking script spendable. I'm sure that's some internal state thing about whether it's been spent yet or not. Custom instructions. Tags, I like that. Output index, output description. Basket. So basket, I'm pretty sure, are like tags that you can tag. So in this case, you'd be tagging an output. Okay. Now I lost my spot. Wallet. So this is basically saying, give me all the transactions that are stored in the wallet, probably with, I don't know if there's any args. What do we got for args? Okay, so you can search within different labels. You can say whether you want any or all of those labels. And then you give information for how you want to receive the data back, whether you want the labels to be included, whether you want the inputs to be included, whether you want the inputs associated output data to be included. Whether you want the output script or unlocking script to be included. Okay, so this is really breaking down a transaction into a more digestible object that that we can kind of parse and make sense of. But it looks like the data is mostly all transaction data itself. And then, okay, so here we have a limit. Here we have an offset. Seek permission. So I think this is going to be does whoever, well, seek permission. I'm sure that has to do with asking the user if they want to allow this to happen somehow. But I'm not exactly sure yet. What does this actually return? This returns list action results. You know, I'm going to close this side so we have more space. I'm going to close this too. Oh, I did already look into that. Yep, that's how I got to where I was. Okay. Okay. So we can query our wallet for what transactions are in there. Storage identity. So apparently there's some. This might have to do with the kind of bidirectional authentication that you can figure out who the server is signing as for you to validate. List outputs. List output args. Let's see what those look like. Same thing. We get a array of tags. So I think baskets must be a kind of a different dimension than tags, in that certain transactions are put in different baskets. I've had a discussion with Ty before about this, but I didn't totally understand. And I think it must just be another level of tags. Also, I believe, although we'll probably find out, that every transaction only lives in one basket, which I don't know. We'll figure that out. Okay, so am I querying one of the tags or all of the tags? Any one or all of? Whether we want to include locking script of the entire transaction, that's cool. Include custom instructions. Okay, are there custom instructions is all that really means. Okay, same kind of stuff back then. And what I'm getting back are just the outputs themselves, probably. Total outputs. Got beef. I guess that would be all of these. If the assumption is that you're querying for a very specific, to build a very specific transaction, maybe this is going to actually return a beef. So beef is basically it's a blob of data that contains a bunch of transactions and the Merkle proofs for a bunch of transactions. And it's gone through a couple iterations where originally it was, so essentially, let's say I'm sending you a payment. And so I would build a transaction that sends you a payment. But in order for you to be able to validate that the inputs to that transaction were valid and on chain, I need to send you also the transactions that the inputs existed in. And so then for both of those transactions, making an assumption in my head that there's two inputs to this transaction. So if I am sending you a transaction with two inputs, well, then I'm going to send you the transactions that contained those two inputs and Merkle proofs for both those transactions saying where they were mined. And if they weren't mined yet and they were still in the mempool, then I would need to go the next step back to their inputs as well. And basically, in V1 beef, you passed a single transaction and every one of its ancestors that basically proofs for every one of its ancestors. And if those ancestors had been mined, you would just include the Merkle proof basically with those transactions. But if they hadn't been mined yet, you need to keep going further back. But ultimately, Beef V1 was all about here's one transaction and its proofs. They've recently released Beef V2, which isn't necessarily about a single transaction. Now there's this concept of an atomic beef, which is basically V2 of that same concept that says here's one transaction. Or there's a more generic blob, which is here's a bunch of transactions, here's a bunch of proofs. It's one package that I broadcast them all in. So I'm guessing this would be such that when we're making a request, we can tell it, okay, well, do we actually, let's go. Is there something in those args that tells us to include beef? Oh, that's funny. I was click back in here and literally it's right above where I just was. I don't see anything in the request that's asking if I want the beef or not. So maybe that's for a different endpoint that can return the same results. Okay. This is all pretty straightforward. Okay. List certificates. I'm going to skip that right now because I don't have total understanding. I know there's some mechanism of having attestations in certificates with Bitcoin keys. I don't know what it is right now, so I'm going to kind of skip that part. Okay, action. So this would be to create a new transaction. So let's go to our args here. So description, input beef. So that's just my proofs for the transaction I want to create. The inputs I want to create, the outputs I want to create. So this is just really giving all the metadata about a transaction, but not just giving it as a raw transaction, giving it as kind of parsed properties. Okay, I'll be interested to see what happens with this. Wait a second, this is implements BSV wallet, I just noticed. So that must mean that there's now a wallet class in the TypeScript SDK. Sure is. Okay. So the TypeScript SDK now has essentially this interface defined. That's cool. Oh, is that actually, that's actually where, that's the file I was working in. Roll it? No, it isn't. I lied. Okay, let me go back down. Getting lost and sidetracked. Okay. Create action. That's what we just looked at, and it returns a create action result, which is transaction ID, it's atomic beef, no send change. And that's an array of outpoint strings. Oops, go back. I just got lost. Oh, I was looking at, no, where was I just looking at? I'm lost. Was I looking at the result? So maybe this is analyzing my transaction that's being built in here. No send change. Oh, that might be giving me an array of which of the outputs of this transaction are actually just my change to myself. So if I want to figure out how much money I sent out, this is telling me which outpoints are my change outpoints, so I can calculate how many satoshis are actually sent out in this. I'm guessing. Send with results. What's a send with result? That might mean that there's a, I don't know what that means. Oops. Signable transaction. Is that a Boolean? No. What's a signable transaction? So it's returning a transaction and it's beef. It's also returning me an array that has other transactions with their beef. I don't exactly know what that is. We'll have to come back to that. Okay, so let's look at what this actually does. So this is just middleware authentication stuff, I'm pretty sure. There's a data validation, probably. Yeah. Do some stuff with the ARGs. Trust self. That's, I'm sure, has something to do with, I don't know. We'll figure that out. Known TX IDs. This ARG have an options? It did not. ARGs dot options. Oh, options right there. Create action options. Oh, that's where it was when I got lost. Okay. So regardless of whether that's populated or not, I am populating that options with get known TX IDs. That takes a parameter. Uh-oh. Did I get lost? Actions. Oh. So basically, there's some concept of known transaction IDs, which are already somewhere, and they get concatenated to the ones that get passed in there. So an array are getting passed in are this beef. I assume there's some sort of concept of like resident transaction or something that populates this, but I don't actually know enough, so we'll come back to that. Call creation. Okay, so if it's a signable transaction, which again, signable transaction has, let me go back to that one more time. Signable transaction has a beef and has a reference. Okay, so I get the beef, I figure out if it's atomic or not, I figure out what's in it. Ultimately, I get to the point, merge beef from party. Okay, so I think what's happening is we've got some concept of proofs for transactions in our system that are not mined yet, I think. And so if I'm creating a new transaction that needs to pull those in to those beefs would need to be merged in with the beef for this transaction in order to have a full proof, maybe. I don't know. We're merging it together. We're returning R, which is our result. Okay. And then that I'm sure is getting returned to, well, let's see if we can find where this is called. All sorts of stuff that's in that other project. Okay. I think what we got here is the BSV SDK, the TypeScript SDK, has an interface. And then there's, I'm assuming, this wallet storage project, which is what we're looking at right now, is either well, it's obviously not a closed source implementation, but it's, I don't have access to view the repo or clone it. I just have it from npm, but at the same time, it's not minified. It's not whatever. So I guess this is really just a sample application that shows one implementation of the API, which is defined in the SDK. It's probably a pretty good reference. I don't know what's calling this. I don't know. I mean, assume. So I know that underneath this whole thing is this, let's pull it up. GitHub, Bitcoin, SV, I think it's called BRCs. So there is this interface that has been defined, which these docs are quite the wiki hole if you start clicking through them. Everything references something else, which references something else, which references something else. But, okay, so this is where all those types that we were looking at are defined. Does it actually get into... So I think the Wallet Infra project I'm looking at is an implementation of this interface, I think. Interface. Yes, okay. So this is probably going to answer most of the questions I had. So this would be the idea of kind of defining, if you've got a, let's say you've got a web page inscribed on the chain. I say inscribed, whatever. There is a web page you are reading off of the blockchain. Right now, if you're using Yours wallet, you can implement the Yours API is injected directly in your wallet. And it has its own properties for getting UTXOs, getting public keys, signing transactions, all that stuff. This is basically, the idea is this would be a standard replacement for the type of thing Yours wallet is doing, that every wallet that's out there would use the exact same interface. So if you're browsing around the Bitcoin web, the applications that exist in that web have a known interface, so they can interact with your wallet regardless of what your wallet is. If it's Yours, if it's a Project Babbage wallet, if it's some new mobile wallet, whatever, they will call the same methods and pass the same parameters. Okay, this helps me kind of get an idea of what exactly we were even looking at with the infra. So this isn't necessarily something that runs in a server, but the same interface probably can get used to do some backup functionality as a, well, whatever. For my main purposes I'm looking at right now, I guess this is mostly about Yours wallet. Okay, let's go back to the code and see if we can't refocus with that knowledge. So these are all method calls that would say, okay, so when I call sign action, I've got some signer configured. That signer implements this sign action. It takes my parameters. So let's actually look at what sign action is. So it's saying which inputs am I signing? Some sort of a reference and sign action options. So accept delayed broadcast. So I'm guessing that's saying, am I signing this to be broadcasted right now? Or am I signing it such that it will be broadcasted at some point in the future? Return TXID only. So I'm going to guess if this accept delayed broadcast is false and return TXID only is true, it will actually sign it, broadcast it, and return just the TXID to you. If true, transactions will be sent to the network by a background process. Okay, so there's other options that we can do. TXID, no, I don't want to confuse things with that. Return TXID. If true, only a TXID will be returned instead of the transaction. Okay, because I'm signing it regardless of whether it gets broadcast right there. So return TXID only just means only give me the TXID back. So I can say no send, which means don't broadcast this. Just sign it. And then send with. And it's a batch of transactions previously created. Okay. So if I'm doing some complex process that involves a number, oh, I have a comment. I was looking at the wrong thing. Okay. Crambo is asking about the wallet toolbox. Yeah, that's probably something I'll take a look at after we're done with this. Let me go back. So if anyone else throws little chats, I'll be able to see them. I don't honestly even know how you chat with these streams. I assume, I know they're going over Twitter and YouTube. It might just be YouTube chat. I don't know if Twitter has its own chat. I really don't know. We'll figure that out when I care sometime. Okay, so basically, this up here is a method for me saying, essentially, create action is saying, build a or have the system know about a transaction that's defined with all these properties. It will build it. There was some change options. We'll have to look at exactly what that means. I don't know if you can, I assume the wallet can probably take an unsigned transaction and add the inputs it needs to pay for it. By pay for it, I mean add the BSV to the inputs, calculate change, add your change to an output, one or more outputs. And then sign action is saying, okay, a transaction that the system already knows about. No. Let's go back here. How does it get the actual raw transaction that it's trying to sign? Or, so let's go back here. Create action as a TXID, but it's optional. There's got to be some identifier that ties these things together. And it probably shouldn't be, maybe it is. So when I call this create action, if I'm telling it to create a transaction that isn't signed yet, well, that TXID is going to change as the signature happens and as other things happen. So somehow this needs to give me, I would think, some sort of identifier such that when I call sign action later, sign action to me either needs to have a raw transaction or it needs to have a pointer to one of these actions that we created. That might be what this reference is. Look at that. How about I just start reading reading directions and comments, and it'll tell me. Reference number returned from the call to create action. Okay, so I call create action. Let's go back there one more time. That does not have a reference number. Oh, signable transaction has her. Okay. So I call create transaction and it might return to me, oh, this is single. For some reason, I thought this was an array. Okay, this all makes sense. I call create action. It returns to me a transaction. It gives me back an assignable transaction as one of the properties. So this would be something then that I could use this reference number to call back into the sign action, and it will sign my transaction how I tell it to. So let's go back, now that I understand this, to sign action args. So here's the reference of, I assume that was an array. No. So I'm telling it which inputs, I assume is what spends means. I'm signing. So sign action must be, you must call it once per input. which I guess kind of makes sense. Okay. So if I want to assign a number of inputs, I guess, so let's say let's say I'm trying to transfer an ordinal. So in that case, I would call create action. Let's actually go through this. I would give it, so I would pass in one input that is the ordinal I want to transfer. I would send in one output, which is, I would assume, the recipient of that transfer. And then just other properties about the transaction, what its lock time is, what its version is, what labels I want to kind of store it under, and then what I want it to do. Okay. Well, let me go back actually into that. No send change. Okay, I don't yet understand how this transaction gets funded. Maybe that happens externally. Maybe the idea is before I even get to this create action, I would have queried, I'm probably skipping ahead here. Actually, it was one of the first things we looked at. I would call list updates once to get what my ordinals are, maybe, and once to get what my funding UTXOs are. So I call it, it gives me back, this is your inventory that this wallet knows about, essentially. So then I, with that, say, okay, this is the ordinal input I want to send. And this is the UTXO or UTXOs I want to use to fund this transaction. Does it ever do change calculation? I suppose that might still be external. It might be external to this. I actually build the transaction. I calculate what the length is going to be so that I can, in a turn, calculate what the fees are going to be. I generate my change. I build the whole transaction externally. I parse all that out into one of these create action args. I pass it in, and that really just sticks it into my local database and maybe takes action with that. Let me go back in here one more time to these options. So then I can also be telling it, hey, when I create this transaction, sign it and process it, do everything all at once. I believe I asked Dagan about this last week. I believe these known transaction IDs is basically saying there are things that we have already validated. We already know them. We already trust the Merkle proofs. And so we don't need to pass around. We don't need to revalidate things that are in known TXIDs. I believe what that's about. That's what that's about. No send would obviously be saying, don't broadcast this yet. No send change. When no send is true, may contain no send change out points previously returned by prior no send actions in the same batch of chain transactions. I don't totally get it yet. Send with batches things together. I get that. Randomized outputs will just, oh. Okay, so I'm guessing like when you get change back or whatever, by default, it randomizes the amount of change in various outputs, and you can tell it not to do that. Oh, this is just the order of the outputs. Okay. So if you're interacting with a transaction where say there's a contract on chain that expects the output transaction to have output 0 be X, output whatever, be very structured. You can tell it don't change those, but by default it looks like, or at least when you set it true, yeah, it is default true. So when you set it true, or you don't set it, it's just going to take your outputs in your transaction and shuffle them, such that there's probably no predictable structure that people can glean information based on the order of output. Okay, I still don't. Okay, so these don't have to have been signed, or these can. All right, let's. Sorry, I'm kind of. So if my input had an unlocking script, this could be a transaction that is already signed, already ready to go. And in which case, unless no send is set true, it's just going to broadcast it when I do this create action. But also I can interact with that same transaction kind of interactively, where I send no send true, and it's in the database, and then I can call it later with a sign request, which is going to basically build signatures. And let's go back then to what did this sign action result? Okay, so this essentially looks up the transaction it had stored. I assume add signatures. I don't know how the adding signatures is going to work, though, because it doesn't necessarily know what the locking script is to be able to add it. So let's see what the send with results is one more time. Okay, I'm missing something here. So if I broadcast my transaction, I don't have any signatures on it yet. It's got an ordinal and an input and a payment UTXO as an input. I say no send. It saves it in my wallet storage. So let's actually go a little further from the top level before we dig too deep. Maybe we can get a better understanding of this. Abort action would obviously mark that transaction as saying, okay, this isn't going to go anywhere. Don't worry about it. Get rid of it. I guess we'll go a little further. So when I call sign action, I'm sending in sign action spend. Oh, okay. Not okay. I'm sending in an array, or a record, but essentially an array of, or I guess it's more of a map, of here is the unlocking script and the sequence number. What good is the unlocking? The unlocking script for the corresponding input. I don't know it yet. Or maybe I know part of it. Obviously, sequence number is needed to generate a signature. I get that part. Maybe this is the partial. Is that unlocking script? That is not optional. I guess it could be empty if. So in the case of it's a pay to public key hash, maybe the pub key is there, but not the signature yet? I don't actually know. Reference, this is the transaction reference, that makes sense. Let's go back to sign action outputs. Okay, these are all about what I want to do with it. This doesn't tell me how the signature is actually applied to the transaction. Maybe it's just prepended to the unlocking script. If that's the case, I'm not sure how you do like op push tx transactions where, well, I guess you'd have everything built up, but what if I have, yeah, I don't think it can just prepend. Let's see, is there any, okay, you know what, let's go over here. See what we get for sign action here. Signs a transaction previously created using create action. Actually, hold on. One step further. Maybe when I created the transaction, no, there's nothing on this input where I tell it it's a certain type of contract or anything. Oh, I didn't need to go there. I actually had it right here. Inputs, outpoint locking. Yeah. I mean, there's a description, but that's just a random string. Signs a transaction previously created using create action. Indexes to the corresponding. Okay. Unlocking script for the corresponding. I don't know the unlocking script yet. Oops. So this returns to me, this doesn't return to me any signatures. So I'm kind of at a loss right now of exactly how this sign method actually, I mean, I understand creating a signature. I understand building and unlocking the script, but I don't see anything in these interfaces that actually tells it how to do that. Okay, I guess let's go through this level. So aborts a transaction as progress and has not yet been finalized. I get that. List transactions, we already looked at that. Internalize action. Submits a transaction to be internalized and optionally labeled. Okay. So this looks like kind of the alternative to create transaction. So create transaction is I'm constructing a transaction through the wallet. But internalize, I think, is saying, okay, take an existing transaction that already exists. We pass in the beef. We pass in kind of how we want to tag the outputs. Okay, it's basically just saying, here is a transaction. Ingest is the word I use for this and a lot of the other things I've been. So internalize and ingest are basically saying, here's an existing thing. So if I want to, from yours wallet, back up my transaction history into this wallet service, that's kind of how I would do it, I think, is using this. I would say, okay, here is, so a wallet, something might go out and hit the one set indexer, get all their history, get all their proofs, and tell their wallet, these are my transactions now. I'll call this internalize. It'll store everything appropriately. I like it. Okay, list outputs, we already looked at that. Relinquish output. Okay, so relinquish output looks like you're basically saying, I don't want this one stored anymore. So maybe you set up a trust for your kids that you're going to unlock at some point in the future. Oops. And you don't want to accidentally spend that UTXO somewhere else. So you create a transaction that should be broadcasted. Maybe it can't be broadcasted for 10 years. There's a lock time rules on it or something. This is basically saying don't keep track of, or maybe not don't keep track of, but this is not a UTXO that I want to be available to spend. Okay, get public key, I get that. Reveal counterparty linkage. Reveals the key linkage between ourselves and a counterparty to a particular verifier across all interactions with the counterparty. So this is basically saying, so kind of the new methodology of derivations is very much counterparty of, I will have a key that gets derived when I interact with you within a context of a certain invoice number. And I think this is basically saying, okay, I can have generated all these derivations, and this gets the information out of that such that someone else can prove these interactions between myself and a counterparty. I think I get it. Reveal specific key linkage. Okay, this must do some other obfuscation or something. Again, this, I don't want to get too caught up on that. Encrypt, decrypt, that's obviously going to encrypt a value with my keys and decrypt a value with my keys. Same thing with an HMAC. Create signature. Okay. Oops, I just lost. So sign action is different from create signature. Is create signature in here? It does not appear to be. Let's see if it's in this project anywhere. You know what? This is probably actually in the TypeScript SDK itself. Let's go there. Actually, maybe it's not. Man, it would be nice if I could type. So let's first here go. Okay. It's just an interface. Okay, this is the interface we're looking at before. Okay. So create signature, I'm passing an array of data hash to directly sign. So I'm guessing if I pass this, this is ignored. Args.data. Data to be signed when using the derived private key with ECDSA required unless directly signing a hash. So if I do hash to directly sign, it will ignore this. If I pass in data, it's going to hash the data appropriately and then sign it. Otherwise, I can have already calculated the hash and then data will get ignored. Protocol ID, this has to do with, there really needs to be a good explainer about this. I kind of get it. It's a concept of basically defining a mechanism for key derivation, and this 0, 1, and 2 has to do with like a, honestly, well, let's try to, actually, let me make a note for myself and we'll come back to that. Maybe. BSV a protocol ID. This would probably be a really good call for me, or this would be a really good topic for me to probably schedule a call with Ty or Dagan or someone and actually just kind of interview through it and have them walk through exactly how this derivation process works. But essentially, between the protocol ID, the key ID, and the counterparty, I believe, or at least the protocol ID and the counterparty, those are all mechanisms for generating derivations. And so there's a hierarchical methodology to it. Again, we'll kind of skip over that right now. So I think to answer my question from earlier, if I want to send, let's go back to my wallet right here. So if I want to create a transaction that sends an ordinal to another party and funds that transaction, so pulls in a UTXO to pay for the transaction, and then also generates outputs to. I do all that entirely external of this wallet infra project. And I sign the inputs completely external. So really, this has nothing to do, this has to do with key management, and I can generate signatures, but it's not going to put them on the transaction for me. So in that case where I want to create a transaction that transfers an ordinal to another person, I build my transaction external to this wallet. I call the wallet and have it generate the signatures I need. So the wallet will take the keys it has stored privately internally. It will use those plus the little derivation rules to derive the appropriate private keys, sign the transaction, and I'm in verify. I'll just go back here because I know I can find it. And give me back my signatures. So externally, I'm still then going to build my unlocking scripts exactly as I would through any other wallet library. It's not part of this process. Then once I have built it how I need to, the create action and sign action, I guess sign action I'm not totally sure about still. But create action is basically going to save that transaction in the wallet storage database, and it's going to allow you to either say it's signed, it's ready to go, broadcast it right now. So again, I don't know if true and all inputs have unlocking scripts. The new transaction will be signed and handed off for processing to the network. Result. So maybe the signing here maybe it must mean just prepend a signature to whatever's already there. That's all I can think that means. But regardless, assuming it's I already have my unlocking scripts, I've already got my signatures, I assume that's just going to mean broadcast this thing. Except delayed broadcast means, do I got to have the result back right now, or is it fine if it just takes care of it at some point in the future? Trust self. I don't know. Let's look at that here, actually. Trust self. If known. Oh, that's the only variable. If known, input transactions. Okay. So basically, this is what I was thinking the known TXIDs is. In fact, I'm sure it is. But this is saying if we already know these transactions, we've already validated them, I don't have to pass the proofs in, and the wallet doesn't need to validate those. It's just going to trust them because they're already known by this wallet. That just says, do I want the whole transaction or I just want the TXID? So if I'm still working with this transaction, this is No send obviously means transaction will be constructed but not sent to the network. Supports creation. Okay. Okay, so I think what I'm figuring out here is sign transaction is kind of the completion of a bunch of intermediate work that's been done with create action. So I can be creating a whole graph of transactions that need each other, and it's an interactive process, and I go through multiple steps to get signatures and update transactions and whatever else. And sign action really, to me, seems to be finalize this stuff that is in an intermediate state from create action. But create action also could have had no send equals false, which is the default, I'm sure. And sign in process true. Actually, sign in process might not even need to be true. That might only be if we're applying some signature process. So essentially, sign transaction means broadcast this batch of stuff I've been working on. Okay, I get that. I kind of like it. So there are some areas where kind of this whole concept is very, very much in line with almost everything else I've been building. But there's also, so in fact, from what it sounds like, this functionality is very similar to, includes, let me rephrase here. If I go back, oh, I'm on the wrong thing. These list actions, list outputs, these are very much the same thing as what the SPV store does. This is how you read data out that has been tagged in certain ways. It is searchable based on labels and buckets or their word, where I've got events and tags on my side. But essentially, everything that the SPV store uses in an event or a tag, I think, could directly map to labels in this. Oh, they actually call them tags. There's labels somewhere else. Okay, so yeah, this absolutely will map. But like in yours wallet, the SPV store is completely independent from the key management stuff. I'm sorry, in yours wallet, key management and UTXO management are completely separate things. But through this wallet infra, they kind of get, I mean, although the keys are still stored completely separate, I guess it's kind of the same thing. The keys are all handled through wallet management stuff. We're not really directly applying any keys or anything here when we're dealing with the transactions. Those use these wallet signing stuff. Oh, wait, that's the same. I don't know. I'm kind of confused, but I kind of get it. It very much aligns with the same way I've been working through this stuff. I'm just not exactly sure the flow. But I think I understand significantly more. I don't know that it provides any sort of like, here's a solution for how I would. So let's say that well, I don't know. Ultimately, when I look at the browser plugin wallet concept, and kind of what we've set out to accomplish with yours, it is not going to be like hitting a server continuously. So essentially, this wallet interface would be built in to yours wallet if we were going to try and standardize with this. I don't think that would be a problem. But the part that I was looking to actually accomplish is external storage of the transactions that are in yours. And I think it could very much be that we also stand up essentially the same create action, or actually it would probably be internalize action. Well, depending on if I'm broadcasting or if I'm ingesting, it would either use the create action or the internalize action, but essentially for how transactions go from an application through to being something that my wallet has signed off on and knows about. And then the next step is and is also backed up to my own remote server that is actually always online, that can receive paymail payments, things like that. I think there's probably 2 layers of this wallet infrastructure, or at least a subset of this wallet infrastructure dealing with actions, creating actions, signing actions, and internalizing actions. That's the part that I would want yours to be also doing too. So every time we call it, every time someone broadcasts a transaction through yours wallet should be reaching out to a server storage place or transaction storage thing that is essentially doing these exact same concepts of, let me add this transaction with my own tagging, with my own whatever, to save it with the appropriate basket insertion. Labels. There we go. Those labels are about transaction labels. There might be some things that still don't quite map out. And I think probably I'm going to try and schedule a call with Ty on stream, or maybe with Braden or someone else from their team, to kind of walk through understanding the real world solutions that are out there right now and how this envision and how we tie those things together. Because I feel like we're very, very close conceptually. And it's just a matter of some minor mapping. All right, well, that's it for this walkthrough. If anyone's got ideas of other things they want either me to walk through like this, or if anyone wants to have discussions on stream where we actually walk through and talk through the details of these things, love to have you on. Yeah. And I have no idea what they're going to talk about, but I see that on Kurt's show today, he's going to have an interview with Connor. Very much looking forward to that. So I'll be in the comments if anyone wants to. I don't pay attention to comments. We're not going to chat, but hey, I'll watch it. I'm looking forward to it. All right. Bye-bye.